We can then use that, run it, and then that is us essentially in that area of the network. So what we can do to open the high voltage breaker, we've just run this.
The breaker opened, so the defenses in the OT network were not strong enough to prevent something like this. This actually happened.
Thales is a large organisation. The kind of strapline for me is satellites to submarines and most things in between. We have an understanding of the complex engineering that our CNI customers have to endure and go through, the highly regulated environments, the complex challenges of interconnectivity and all the dependencies that they've got then on other systems or that other systems have on them. A lot of what we do is in the operational technology space, so cyber-physical systems. The ability to have a sandbox environment where we can train, test, and exercise in the cyber context is really important. A safe pair of hands is how we try and position ourselves.
We specialise in building and breaking. I think a lot of people are surprised when they come here. It's almost like a toy store for adults, cyber adults. We've got a lot of real stuff that you will see out in the actual field, connected in the same way. Might not look exactly the same because it's in a nice compact bench, but it is the exact same equipment. We're able to connect them to our cyber range, so we have both the IT and the OT side, and then we get to just let rip on it and break it. That allows us then to give that information to customers and show them that we can make it safer and how they can implement that into their business.
What the range allows us to do is we can show all the different sides. So we can show the victim, the sort of business operating as normal. We can show the actual equipment in the labs, and giving that full story behind it can help make it more real to a customer, a potential customer. And a lot of the times they don't realize it was that easy.
Cables, there's a small logic chip and Wi-Fi antenna. He's one of the guys that we've targeted. We've walked up to him and gone, "Hi, do you want us to recharge your cable?" He's gone back to his job, walked up to the smart grid and he's realised, I need to charge my phone. There's a USB port available on the front of the smart grid itself. So what we'll see is we'll see our engineer plug that cable in.
We have more and more energy companies coming to us. SEL have a very good reputation in quality, reliability and innovation. Who better to have partner for a state-of-the-art testing lab?
The partnership combined SEL's expertise in power system protection, automation, communications, and OT cybersecurity, together with Thales's deep cyber resilience expertise, their national scale defense, and their attack simulation capabilities. Together, we provided a state-of-the-art smart grid laboratory for UK energy utilities. The core SEL contribution is our next generation protection, automation, and communication products. This includes our emerging units, which are built for digital substations, and our protection relays that are all based on IEC 61850. A digital substation replaces legacy copper wire with high-frequency digitized signaling. This emphasizes the need to be able to strengthen the network in the system. OT software-defined networking forms the backbone of digital substations. The lab provides a space for utilities to test real-life attack scenarios, strengthen their resilience through cybersecurity training, provide them the opportunity to test different network architectures, and go through different attack simulations to understand what to do and what not to do in their network designs.
Building the demo was a sort of very useful experience with the team at Schweitzer. A lot of our demonstrations rely on some form of social engineering where someone just clicks a seemingly harmless link, which surprisingly I think still is one of the top sort of ways of initial access. Our attacker here is posing as the email address of that machine that they're in. So it's a trusted person, it's a trusted address. But as soon as this link is clicked, it'll pop up a warning, which is when the alarm bells would start to ring a bit more. You'd cancel out, you'd delete the email or report it, whatever you like. But you may have seen in the bottom right of the attacker's interface, they actually got the credentials passed to them. We can run through the initial attack. We can show the attacker getting that full sort of network takeover, and then the result, which could be OT systems in the labs going catastrophically wrong. You start getting connections in from a lot of different IP addresses, and so you'll see all of these sort of bug icons start to appear around the map. and then we can revert it all back to that initial point, and then we can introduce the OT SDN, and that connection's not allowed because they need to request it, and so it stops the attacker at that point because they're not able to sort of do anything without raising a few more alarm bells.
Software-defined networking by default rejects anything that's not policy-based. We know where the gooses is going, we know where sample values is going, so ahead of time we know what that data flow looks like. If we use microsegmentation and if we can use software-defined networking, we're moving ourselves to an element of zero trust.
It's good seeing a visualization of, a sort of a cyber attack and how it might affect OT. We're not in a position we can throw loads of stuff away and start again. We have to work with legacy equipment and new equipment side by side.
If you've had an attack that happened, or if you have certain security controls that you want to put in place, we can play that back here. Test out things that you want to do in your system before you implement them.
A facility like this, articulating the issues that we face and starting to look at how we might deal with them as an industry is good news.
The future is really bright. We have a really strong expansion plan to include larger digital substations, more OT software-defined networking demonstrations, and teaching of microsegmentation for different architectures and different industries, extension towards the distribution network and including the last mile to the recloser networks, and implementing microgrids and DER-based systems. As threats evolve, the lab will grow into a center of excellence for secure, resilient, zero-trust-enabled infrastructure in the UK.